Hi class. Today we are going to be talking about monitoring and evaluation. So this is the very end of the project life cycle, but it's super important and it informs future projects. All right. So monitoring. Why bother? Nobody wants to pay for this anyway. Funders typically want to construct and build a project and walk away. There are exceptions, of course, but on the whole, it is hard to employ biologists and ecologists and other professionals to do pre and post effectiveness monitoring. This is a little dangerous in that project failures can occur when no one's paying attention, when no one takes simple corrective action, and we'll look at some examples. But monitoring is important, and what I would say to make that case is that it determines whether the project actually met its objectives. For example, you may have an objective to reconnect the hydrology of a wetland. That's easy to see. You build a bridge, you breach a dike, you install a culvert, ta-da, here's water. But there are other objectives that are on longer time frames. So if you had a sub-goal to install native plants and introduce habitat complexity, well, you won't know if that was successful for several months, if not a couple of years. So if you walk away from the project too early, you don't honestly know if you've met your project objectives. Now, monitoring also leads towards evaluation and adaptation. Those are different things. So monitoring informs evaluation, and what I mean by evaluation is a decision about whether or not the project is working. And adaptation is when you have an opportunity to go back and make some changes to help it work better. So monitoring is the data collection during the aftercare phase, whereas evaluation and adaptation is a feedback where you learn from those monitoring results and you either do nothing because everything's going great, or you do something because the project is responding in a way that you didn't anticipate. It is important to monitor and to respond to unseen circumstances because nothing sets back your reputation both as an individual project manager and as an organization like a project failure. Here is a very colorful example. This is the Animas River in southern Colorado, and there are lots of old mines in the upper portion of the watershed that leach all kind of acidic, toxic water. They're a legacy of the metal boom that occurred in that area. There was a lot of silver mining and various other commodities. And those companies walked away a long, long time ago, generally speaking, well before there was any kind of notion of environmentalism or even any notion of environmental regulation. So it's a legacy of a former time. But now the Environmental Protection Agency and other local groups are trying to mitigate the leaching of toxic water that's coming out of these mines, and sometimes they'll build containment ponds to contain that water at least temporarily until a better solution is discovered. And in this case, an EPA contractor, so somebody the EPA hired to maintain one of these containment ponds, the contractor screwed up and ended up releasing a ton of polluted water into the river system. And within hours, you went from a pristine looking river to a very scary looking river. And there were concerns, and there still are concerns about long-term ecological health and long-term human health. I think it remains to be seen, now that the river is looking good again, whether those contaminants have a legacy. But in any case, the point of this is that monitoring is important and very careful project aftercare is important so that you don't have a situation on your hands where you get massive blowback from the public who is outraged that something like this could happen. So what do you do when you go monitor a site? Well, you document everything that's occurring at that site over time. So maybe you're documenting fish use or um, changes in the hydrology or changes in vegetation, but you just try to document everything that's happening there. And your time frame is up to you. It depends on your resources. But other things you can do when you're monitoring is to evaluate special techniques. So for example, you heard me talk about Otter Point and how we tried some innovative things there regarding weed control. So one of the monitoring activities was to really see which portions of that property had the fewest weeds after the project was done. And that informed which technique we thought was the most useful. And that's the technique we went with in future projects. So sometimes it is important to do a little experimentation with techniques and see what works best. Monitoring also encompasses verifying that the project was executed as designed. So hopefully there are no surprises. You were on site, you did correct as-built drawings, and everything was executed as planned. But sometimes you discover stuff later, where a contractor didn't quite build it to plan or cut a corner and it wasn't noticed. And so that's something that you can pick up when you're doing monitoring, and you can take corrective action. And finally, it's important to establish a database for planning subsequent projects. So maybe you're monitoring a site, or maybe you're monitoring a nearby reference site, and you're using that data to inform future projects. That's what I mean by that. Those are all very important functions of someone who is doing monitoring, and that may fall to you as a project manager. How do you plan for monitoring? Well, like everything else in this course, you build a plan, like literally a document where you lay out the monitoring plan and you tie it to the project objectives. So you lay out your project objectives, and then underneath each of those objectives, you determine which methods you can use to test those objectives. Basically, you're trying to very clearly articulate the link between the objectives, the performance criteria, and your monitoring actions. So if you have an objective to reestablish, I don't know, Sitka spruce on a site, well, you might link that to performance criteria related to native vegetative communities and what you expect to grow there over time. And then you might actually get out there and survey for Sitka spruce multiple times to see if they're established and to see if they're surviving over time. Again, incorporate reference site data if you can, and understand that nothing is static. So there is always natural variation, and there's always natural disturbances. So your project isn't a straight line from A to B, where A is disturbed and B is pristine. It just doesn't work like that. You know, we've all had to get used to the idea of living with non-native species. Hopefully we can keep them in balance with the natives, but that's just an example of variation that is going to come into your project plans whether you like it or not. So you don't want to be too attached to the outcomes and the objectives, but you want to make sure that on balance you're achieving them. So your monitoring plan will also specify what data to be collected, how often, the methods, and how it's being paid for. And you can find examples of monitoring plans online for a number of restoration projects if you'd like to have a closer look. One important element to all this is keeping consistent data sheets and consistent record keeping. It's not uncommon for staff turnover to result in new people being hired, and they're asked to go monitor such and such project, but they don't know what's occurred there already. And with monitoring, with any kind of research, it's essential that you have consistency. So documentation and communication always is critical as a project manager. Now, sometimes you don't have to make this stuff up. You can refer to standardized protocols. So, for example, CREST helps develop these protocols for monitoring habitat restoration projects in the Lower Columbia. And what that did was provide standardized instructions for any group monitoring restoration in the Lower Columbia, because there's a bunch of groups. So everybody started doing the same kinds of activities when it came to monitoring and evaluation. And that made results more comparable across sites, which is really hard to do. So it's worth having a look to make sure that someone in your region hasn't already developed monitoring plans that you can just apply to your particular project. This really helps with transferability, helps the entire region learn from one another, and it just strengthens the validity of your findings. All right, in your book, Table 13.1, there is a compilation of monitoring characteristics, attributes, and frequencies for various restoration sites. So it gives you some suggestions. So, for example, if you want to monitor the salinity of water, maybe once a month is ample. It just depends. You know, if it's a saline lake, once a month should be ample. If it's a saline coastal wetland, you might have a probe in there that's measuring salinity every hour or every minute. Topography, elevations. That's probably something you want to verify initially after the project, and then opportunistically after big storm events, for example, or floods. Let's have another example. Consumers, so pollinators. Maybe that's something you go monitor seasonally. This is a very comprehensive list, and it's extremely uncommon for you to have the resources to do all of these things. It's more important that you select from these things according to your project objectives. So always refer back to the project goals and objectives, and then figure out which of these is appropriate for each of those monitoring objectives. All right, I'm going to walk you through some typical pre and post monitoring metrics, at least for the type of work we've been discussing this term. So with wetland restoration projects and many ecosystem restoration projects that involve changing the hydrology, these are some of the things that you may be tasked with monitoring, or you may hire someone to monitor. You want to monitor the physical environment. So let's imagine your stream network has changed as a result of the restoration. So you want to quantify the change in extent, so the change in surface area of those channels. You may also want to monitor the channel slopes, like this in the lower right-hand corner. Maybe you have a changing depth profile to those channels, and that's how you're demonstrating the maturation of the site. Channel features, you know, where you have woody debris, where you have a head cutting channel feature. I'm not going to get into too much hydrology here. Water elevations, water quality, sediments. These are just many of the physical features that are worth monitoring. Biological. So when you want to monitor plants and animals, at a minimum, you should be doing photo points. So taking photos in exactly the same location over time so you can see how the vegetative community is changing. Um, Ideally, you'd go a little further and you'd actually do plant surveys or either plant plots or transects to, in a deeper way, quantify that change. Wildlife is a little trickier. You can do presence absence with camera traps, with tracks, or with actual trapping, or you can just have observers on site at a regular schedule to see what they see. Um, with salmon, with fish, it can be much more intensive. It just depends, again, on your objectives. Large projects might actually benefit from a research advisory committee. And I have seen this work before where there's a high degree of interest in seeing the response of a particular restoration project, and there's a good deal of money being invested in the monitoring. It does help sometimes to bring in some experts, sit them around the table, and have them help you fashion the monitoring plan. So maybe you need to have a fish biologist and a botanist inform the metrics you're going to be collecting. Let's see. I'm going to show you some of the things we did at Crest, just so you can get a better sense for this. We were part of a regional effort to try to understand the cumulative effects of all these little restoration projects. It's hard to say, for example, that one small restoration project, say 30, 40 acres, is going to have a massive impact on salmon survival. We suspect, though, that when you do a lot of these projects throughout the lower Columbia, that they add up to some meaningful nudge in the right direction, some meaningful bump in juvenile salmon survival, and hopefully adult returns. It is still very hard to quantify, but we collected data consistent with other organizations that we thought would help tell that story. Fish community parameters. So we put out these net traps that capture all the fish leaving a site at low tide, and we were able to document what species, how big. We took genetic material so we could go even further to understand which watershed they came from originally. We also did some seining with nets in the main channels, the adjacent rivers. We also did prey utilization. So on a subsample of these salmon, we would do gastric lavage, where we would basically empty their stomach contents to see what they were eating and try to determine whether if what they were eating was relatable to the actual restoration site. So you do everything you can when you have the resources to quantify the value of that project. All right, in terms of understanding change in the physical habitat, these are some of the typical metrics. We would measure water quality either with hand instrumentation or with continuously monitoring probes that we installed in the water. And that would be things like dissolved oxygen, temperature, and salinity, and depth. And then we would make measurements on the vegetation. We'd do some veg plots. We would do sediment accretion, and that's this picture here, where you install a level and you see if the sediment accumulates more over time. That's typical of wetlands that are reconnected, is that you have an influx of sediment, and so you will see the elevation of the site change over time. And then we would do more in terms of assessing the change in the channel network. So we had biological metrics and we had physical habitat metrics. The sampling design was before and after, and then we were also comparing to a neighboring reference site, which is really helpful to understand what a naturally performing ecosystem is doing compared to your restoration work. Hopefully they're in alignment. that you see similar trends in both, but not always. And that informs whether your restoration was designed appropriately or not. I've shown you some slides like this before where post-restoration we see an immediate uptick in wildlife usage and an immediate change in the plant community. So it does go fast. But if no one's there to do the measurements and do the monitoring and respond if necessary to things that aren't working well, and if no one's there to tell the story of the success even, then the public is disinterested. And that's part of this too, is doing this kind of monitoring helps you tell the story to the larger public and keep them enthused about this type of work. And that's really important when you're working in small communities. It's also really important to keeping funders and permitting agencies on your side as well. So that's all I'm going to say about monitoring and evaluation. You'll be hearing from others about additional case studies, additional examples, and they'll have a lot more depth to go into. But thank you for your attention. I really appreciate it, and I will be seeing you soon.